Good day everyone. Welcome back to our engineering mechanics lecture series. In the previous lecture, we studied the basic concepts of friction and the procedure of friction analysis. In today's section, we are going to apply those concepts to a wedge problem. A wedge is a simple mechanical device used to raise or move a load by applying a force. We will learn how to isolate the objects, identify the frictional forces and normal reactions, apply the equations of equilibrium and finally determine the required force. Let us begin with the given problem. In this problem, block A has a weight of 1500 newtons and wedge B has a weight of 500 newtons. The wedge angle is 15 degrees and the coefficient of friction is 0.2. Our objective is to determine the minimum force required to move block A upwards. First we isolate block A and B separately and identify all the forces acting on each body. The free body diagrams show the weight, normal reactions and friction forces at the contacting surfaces. Now we resolve the forces into their horizontal and vertical components. For block A, the weight acts vertically downward. The normal reaction acts perpendicular to the inclined surface, while the friction force acts along the contact surface and opposes the tendency of motion. The same approach is followed for wedge B. These force tables help us organize the horizontal and vertical components before applying the equilibrium equation. Now we apply the basic equations of equilibrium since the blocks are considered to be in equilibrium at the limiting condition. The sum of the horizontal forces and the sum of vertical forces must be 0. Therefore, we use sigma fx equal to 0 and sigma fy equal to 0. By substituting the forces, components and friction relationships into these equations, we obtain two equations involving the unknown reactions. From the two equilibrium equations, we substitute one equation into the other. This gives the normal reaction between block A and the wedge. The calculated value of Na is approximately 1807 newtons. Using the friction relationship, the corresponding friction force is approximately 361.95 newtons. Now we move to the wedge B. The wedge is subjected to its own weight, the applied force B, the normal reactions from the ground and the forces transmitted from block A. The force components are again resolved into horizontal and vertical direction. This gives us the required force table for applying the equilibrium equations and wedge B. From the vertical equilibrium equation, now we apply the equilibrium equations to wedge B. From the vertical equilibrium equation, we obtain the normal reaction from the ground. Then use horizontal equilibrium, we calculate the required pushing forces. The calculated minimum force is approximately 1247.2 newtons. After completing the equilibrium calculations, the minimum force required to move block A upward is obtained as 1247.2 newtons. Therefore, this is the required minimum applied force for the given wedge systems. Let us summarize the procedure used in today's problem. First, isolate the object. Then, identify the active and reactive forces. Third one is indicate all the required dimensions. Next, prepare the force or moment table. Then apply the equations of equilibrium. Finally, solve for the unknown quantities. This systematic procedure is very useful for solving frictional analysis problems accurately. With this, we have completed today's lecture. In the next section, we will continue with another important topic in engineering mechanics. Thank you for your attention and see you in the next class. Thank you.